Hi there, welcome back. In this video, we're going to take a look at valid binary search tree problem. So what we're given is a root element, and we need to implement a function that checks is this valid binary search tree or not. So we need to return Boolean. So let's quickly recap about trees and what a binary search tree actually is. So for trees, we know that we have a node that has left and right children. So 1, 2, or none. If the node doesn't have any children, it's a leaf node. And what binary search tree adds on to the tree properties is that every child on the left side needs to be smaller than its parent, and every child on the right side needs to be bigger than the parent, right? If this is the case, we have a valid binary search tree. So let's check the first example, if it's valid or not. So all of the children from the current parent to the left side are smaller, see here. And for the right children, it's the same, right? So this is valid binary search tree. What about the next example here? So the left side is the same as the above example, so it's good. And if we look at this subtree here, we see that 9 is smaller than its parent, which is 20, which is good, and 30 is bigger. So this is valid binary search tree, subtree. But if we take a look at this, so every child here needs to be bigger than its parent, but we see here that this guy is not, right? So because of this guy, this is not valid binary search tree. So let's talk about how to solve this problem. One way of solving this would be to have a low and a high range, right? So we can start this range with low like being minus infinity and high being infinity, right? So we just check, okay, cool. Is the current value between minus infinity and infinity? It is, cool. And then we traverse down, right? Now when we traverse to the left, the low stays the same, but the high becomes apparent, which is 10. And we check, is 5 between minus infinity and 10? It is. We go to the left. Because we don't have any more children, we just return true, right? And the difference between going to the right is that when we go to the right, the high stays the same, which is infinity in this case, and minus in the low becomes the parent, which is 10. And now we check, is 20 between 10 and infinity? It is. And we traverse until we hit the end, right? And if any of the value is false, we return false. If it's true, we just return true. And that's it. So let's talk about time space complexity. For time, we can say that we need to traverse all the tree, so it's of n. N is the number of nodes in the tree. And for space is a little bit tricky because we're actually not using any additional space. We're not allocating any additional variables or building an array or such. So we would think that this is of 1, right, constant. But because we'll be building a recursive function, it's actually of h. So h stands for the height of the tree. Because every time we will call the recursive function, we will build space on a call stack, right? Cool. So let's look how this would look like in code. So we will need is valid bst function, and what we'll return is Boolean, right? What we'll be building is this tree. So we have a root value 10 and then 5, 20, 30. Let's quickly create class node. We have a constructor, so self value, so left has initial value of none, and of course for right. Cool. Left and right. Cool. We need root values as well. So we have node. So the root is 10, and the left value is 5. The right child is 20. Let's have this guy be correct, so it's it can be 15, right? So we'll have 15 and 30, like this. Cool. Let's implement the function. Ref is valid bst. It takes a node, and because this is a recursive function, we'll check if not node, we can just return true, right? Now, when we call the root node, we can say, oh shit, we can say, yeah, so the low can start as minus infinity, so float minus infinity, and the high start as float infinity, like this. Cool. So at this point, when you check if there's node, so we actually have a node, we need to compare if the current value is between those values, right? But if it's not, we just return false. Okay, cool. So let's do that. Low is between node and the high. We return false. If not, we will be traversing the tree here. First, let's do it for the left side, so node.left. And when we're going to the left side, low stays the same, but high is node.value. Okay. And now we need to do the same for the right. So when we go to the right, becomes the parent, so node.value. And for the high, stays the same, like this. Cool. Yeah, let's run the code. Let's see what happens. It's true, but if we, let's say, change 15 to a 9, it should be false, and it is. Alright, cool. So that's all for this one. Hope this helped you. Yeah, see you next time. Bye.